All right. You will be having a test soon. I'm not exactly sure when yet. So, but I should be letting you know probably the end of next week is my guess. All right. So here we go. You'll notice today on the class practice, it's page 8. You have a little small group of problems, and then page 22. So 2 different pages on the assignment. And make sure that you write the original problem. ORIGINAL. So write down the original problem. They're short, they're easy. It's really important that you do that because when I mark it right or wrong, okay, if it's wrong, you need to reference the original problem to see if you can figure out your mistake, okay? All right. So here we go. We've got some properties to write down.
There's only a Joseph on it.
Probably. Yeah, a lot of go by the middle names sometimes. So, properties of addition and multiplication. So the first thing, we're gonna write these down. These are in the textbook, but it's just you guys don't really have a textbook at home. They're in page 5 of our textbook. You're welcome to take a picture. Yeah. No, 2 lines. 2 is not one. No, not a time. All right, so these are traditional properties of addition and multiplication. These are the properties that we use to help us solve equations, and so it's kind of important that we know them. The first one is the closure property. Closure property is kind of weird. If I write it, you write it. Yeah. All right. You will have to identify these properties in your homework. So this is why we write them in notes, so you have a reference point to look at, okay? The closure property is kind of a weird one. We don't talk about the closure property too often because it's like, well, duh. I mean, it's pretty much what it is. The closure property says that if I take any number I can think of, any real number like the number 4, and I add another real number to it, like the number 9, that is another real number, then the result, which is 13, is also still going to exist in our real number system. It's like, well, duh, of course. If I add a number to another number, it's still going to be an actual number. Okay? Kind of weird. And the same is true if we multiply. If we multiply any real number times another real number, then we're still going to end up in the real number system. Okay? And that's, I don't know. It's a weird one, and I'm like, well, okay, sure. Yes, sir.
Oh, what's not a real number?
That's a good question. I don't know. So that's why this is like, well, duh, what other number can we think about? Yeah, I don't know. Oh, so the things that aren't real numbers are imaginary numbers. Okay, so there's real numbers and there's imaginary numbers. But yeah, the real numbers is just it's kind of real. Yeah, there are imaginary numbers, ladies and gentlemen. You're going to learn about imaginary numbers in this class. Okay, so we'll learn about that in about a month. Okay, crazy. Okay, so here we go. The commutative property. The commutative property. I like to think about the root of the word commute. Commute, like when I commute from home to work and work to home. I go the same distance, no matter which direction I go. All right, so that's what I think about with the commutative property. As an example, 3 plus 4 is the same as 4 plus 3. That's the commutative property. We get the same results even if we add them in a different order. So the commutative property has to do with the order. Changing the order does not change the answer, okay? In addition. The same is true for multiplication. 5 times 4 is the same as 4 times 5. The order does not matter. The commutative property deals with order, okay? Does that hold for subtraction? No, it does not. 7 minus 5 is not the same as 5 minus 7, okay? So that's why these properties are only true with addition and multiplication, unless we do some tweaks, okay? All right, the associative property. I like to think about who you associate with. The associative groups. The associative groups are what we're talking about when we use the associative property. That says, if I want to say add 3 numbers together, 2 plus 3 plus 4, and I tell you with grouping symbols that I want you to add 2 and 3 together first, that's going to give us the same result if I take those same numbers, but I say, hey, I want you to add 3 and 4 together first. Do we get a different result even though we change who we add together first? No, we will still get the same result, okay? So here you can see that on the left side, the associative groups, the grouping symbols changed from left to right. Same is true with multiplication. 2 times 3 times 4. And if I tell you to multiply 2 and 3 together first, it's going to be the same as if we multiplied 3 and 4 together first, and then the 2. All right? All right. Identity. The identity property, I like to think identical. If I start with some number, any number 27, what can I add to that number so that I get the identical thing that I started with? 0. Sure. I can add a 0, and that would be the identity property, where whatever we started with is identical to what we end with. Does that make sense to you? Are these weird? It's like, well, duh, right? Okay. So that's the additive identity property. The multiplicative identity says, hey, if I start with a number and I multiply by something, what do I multiply by so that I get the identical thing? 1. Okay? So the identity property would be when we multiply by 1 or add 0 to get the identical thing out again. All right. Inverse. The inverse operation is what we use most of the time when we're solving. And so we have the additive inverse. If I have 3, what number can I add to it so that it disappears? -3 is correct. -3. These are additive inverses. One is positive, one is negative. Those are inverse operations, and they add to equal 0. They cancel each other out. They undo one another. That's what inverse means, okay? Multiplicative inverse. 4 times something is got to cancel it out. Now, in multiplying, it doesn't disappear. It actually cancels out and reduces to 1. 4 times what is 1?
4.
4 times 4 is 16.
There you go. Sorry.
4 times 1 is 4. 4 times -4 is -16. 4 times 0 is 0. Okay? Lots of guesses. Those are good.
Oh, 1/4.
1/4. Winner, winner. Good job. 4 times 1/4. These are inverse operations. And technically, 1/4 is the same as like multiplying by 4 and dividing by 4. All right? Multiply by 4, divide by 4, cancels out, reduces to 1. So these are inverses. They undo one another, cancel each other out. Okay? The last one is the distributive property, which you all should know and love. If I have something like 3x plus 5, I want to apply the distributive property. What does the distributive property do? It distributes. Yeah, right? I mean, how do you describe that? They multiply, right? So that's saying, hey, take this 3 and multiply it to each term inside the parentheses. So we would say 3 times x, and then what? Plus 3. I'm going to say 3 times 5, because that's how the operation works. We usually do that step in our head, though. You're right. So that is the distributive property, which hopefully you all know and love. So the first few problems on your class practice today just are, hey, here's an example. What's it called? Okay, is it the closure property, the identity property, the commutative property? Okay. Any questions on those? I see a few hands still writing, so give me a second here. All right, here we go. Example 1. Example 1. Remember, you need to write these directions. Example 1, solve the equation, check your solution. I'm going to say it now so I don't have to repeat myself during class. Your directions on your class practice today say solve the equation and check your solution. So how do you check your solution? What are your options for checking your solution? Grace. Okay, so plug it back in. That would be the numerical way of checking. I will show you how to check that way. Plugging it back in. What are some of your other options for checking your answer? Use your calculator. You can use your calculator. Okay. Yeah. So that's what happens when we actually do check it numerically or with a calculator. I was being more like abstract. You have neighbors. Could you ask a neighbor? Yeah? Okay, what'd you get for 22? Could you check your odd numbered problem in the back of the book? Oh, yeah, that's right. Could you check with the teacher's edition? Oh, yeah, you could do that, okay? So I want you to check in a variety of ways, whatever is most simple. Now, in terms of physically checking it with math, do I want you to do that? I want you to do it once or twice to make sure you know how. Because on a test, you don't have those other options like a neighbor. You can't phone a friend. You can't check in the teacher's edition. So you need to know how to do it yourself. So I want you to just check 1 or 2 just to make sure you know how to do it, okay? So here we go. We have 2 9x plus 8 equals 16. When we're solving an equation, our goal is to isolate the variable. And so if we want to isolate the variable, what is a variable? A letter, the unknown. Yeah, in this case, x. Over here, it's an n. It's whatever letter. We're trying to figure out the unknown. So good. So we want to try and isolate that x. And the way we want to do that is starting using addition and subtraction. So is there anything that's on the same side that we can move away? The 8. So how are we going to move the 8? Subtract. That would be the inverse operation. You can see that it's a positive 8. The inverse operation is negative 8. And of course, whatever I do on the left side of the equals, I have to also do on the right. Additive inverse adds to be 0. We're left with 2 9 x is equal to 8. Now, this is 2 9 times x. How do I get the x by itself? Okay, so I usually hear divide. What are you going to divide by? 2 9? Sure, you can. And that's really weird, isn't it? So what is the multiplicative inverse of 2 9? 9 over 2. 9 halves, also known as the reciprocal. So we can multiply by the multiplicative inverse. We're going to multiply both sides by the reciprocal. What happens when I have this 9 halves times 2 9? It's 18 over 18, which is 1. And that's always the goal, to have a 1x. Over here, I have 8 times 9 halves. How do you do that? 8 over 1. Very good. And you can go straight across there. What's 9 times 8? 72. And 1 times 2 is 2. And what is 72 over 2? 36. Very good. So again, ask your neighbor, what'd you get? Check in the back of the book. Check the teacher's edition. I'm going to show you how to check the next one numerically. All right, so we have 12n minus 3 equals 4n plus 21. On the first example, we only had one variable. Here, we still only have one variable, but they're on both sides of the equal sign. So we really need to do our job to get them together. They're friends. They're like terms. They want to be together. So we need to get them on the same side. What do you guys want to do first? Subtract 4n. Good. And again, that's the additive inverse. This is a positive 4n, so we're going to do the opposite. And the reason we're doing the opposite is because positive 4n and negative 4n add to be 0. And then 12n minus 4n is 8 n's. All right, what else do we need to do? Add the 3. Good. Again, the inverse operation, the additive inverse, we've got a negative 3 and a positive 3. We're going to add 3 to both sides. So we get 8n is equal to 24. And then what do we need to do? Divide by 8. Divide by 8. Very good. So n equals 3. Very good. All right. I want to show you how to check this one. Now, when you check, you're going to take your value and plug it back in. And I'm going to say you're going to plug it always, always, always back into the original equation. How come you want to plug it back into the original equation? I love asking this question. So, could I plug it in here to 8n minus 3 equals 21? I could. You certainly could. But I also could have already made a mistake. All right? So the reason we plug into the original is because hopefully it's error-free. Does that make sense to you? You don't want to check in something that could be wrong. All right, so we've got 12, and I'm going to plug in that 3 for the n. Minus 3 is equal to 4, and again, times n. My n is 3. And then I'm going to add the 21. Now, when you check, all you have to do is simplify each side. Is that something you could plug into your calculator? 12 times 3 minus 3? Sure, you could plug it into your calculator. You could do it in your head. What's 12 times 3? 36 minus 3? 33. And we want to know, does it equal this right-hand side? 4 times 3? 12 plus 21? 33. Does it work? Yay! We did it right. Okay? Always a good idea to know how to check your answers. Check for balance, okay? One more. Last one. Multi-step equation. All right. Letter C, we have 5 times the quantity. X minus 2 is equal to negative 4 times the quantity, 2x plus 7 plus x. Again, if you know how to do this, great. Go ahead and do it. Do it on your own. This is a multi-step problem. What do you notice about this that's different than the others we just did? We've got to distribute. We've got to use the distributive property. We've got grouping symbols. And so since we have those grouping symbols, the very first thing we need to do is distribute. All right, so I need to distribute this 5. So it's going to get multiplied into those parentheses. What do we get when we distribute? 5 times x is 5x. And this is 5. I'm going to say you always include the sign in front. The sign to the left is part of the number. So when you read this, you should say 5 times negative 2. 5 times negative 2 is negative 10. It's not technically subtraction. It's a negative 10. All right? Over here, I'm going to do the same thing. I'm going to distribute the negative 4, including that sign to both terms inside the parentheses. Do I distribute to this x out here? No, it's not in those parentheses. Negative 4 times 2x. Negative 8x. Negative 4 times positive 7 is negative 28. And I'm going to bring that plus an x along for the right. All right. Now we have a lot of x's. What do we need to do? Add them together. Combine like terms is what it's called. Before you move anything left and right, you should always look for like terms. So on this right-hand side, I've got a negative 8x and a positive 1x. When they're on the same side, you just do what it says. What is a negative 8x and a positive 1x? Negative 7x. When they're on the same side, you just do the same thing. When they're on opposite sides, what do you have to do? You got to do the opposite. Okay, to get it to the opposite side, you got to do the opposite. So I want to get my x's together. What should I do? Yeah, let's add 7x. Add 7x. Got to do the opposite since we're moving from the right-hand side to the left-hand side. 5x and 7x is 12x. Wow, lots of 13s for that answer. Second period did the same thing. It's so interesting. 5 and 7 would be 12. Okay. Now what do you want to do? Add 10. Add 10 to both sides. So negative 10 and positive 10 adds to be 0. Negative 28 plus 10 is what? Negative 18. Yeah. 28 negatives and 10 positives. The negatives are going to win by 18 people. All right, and the last step, divide by 12. Divide by 12. 12 divided by 12 is a 1x, which is what we want. And this is a lovely fraction, but we need to reduce. So what can we divide by?
6.
We can divide by 6. Very good, yes. So yes, we do get 18 divided by 6 is 3. Negative 3 over 2. Negative 3 over 2. So beautiful answer. You will get fractions as answers. Just make sure they're reduced. Okay? Ladies and gentlemen, do you have questions for me? Okay, get going.